Okay, in this video we're going to look at match pairs and then wilcoxin test. So first of all, match pairs. So for match pairs, I have some data x and y, and both of these were recorded on the same subjects. So if we look at x, here's the responses, and this is the one on the first subject, the second subject, the third subject, and then y again. So first subject, when they had treatment X, they had 1.12, and then treatment Y 1.72, etc. So these on the same subject, these on the same subject, these on the same subject, and these on the same subject. So if we want to do a match pairs, we do t-test as before, but now we put in the X and the Y, and then we let it know that it's paired. And there's the thing, so its test to say is, if we took the difference between each of these, and then we test if the population mean is equal to 0 for the differences. And that's why it's done automatically. Now, you could test that, you could actually create the differences, like that. So if we look at diff, you can see this is the difference between x minus y, etc. Now we could do a t-test of this. Hopefully what you see is that we get exactly the same output. So what R is doing is actually, because you said pairs 2, it's doing that calculation for you. Now the next data is in a thing called data frame, and here we have two treatments A and B, and we have the responses on A and the responses on B. But if we do, for example, a QQ norm, well, first of all, let me just get the ones that are A. So if I just go treatment A equals, we do a subset of the data frame, such as the treatment equals A. So we look at treatment A, just got the A. If I now do a QQ norm of these, it looks reasonably normal, but it's hard to say. We've only got a few points. But in this case, we're going to assume we haven't got normality, and we will try actually doing a wilcoxin test. So I go wilcoxin test. So my response variable is my y, then my treatment. I'll let it know what the data is. And there we are. Testing to say, is the location equal to 0 between these two? We've got 83 for our W, our p-value is 0.0115, so we would reject that and say there is a significant difference between A and B. Okay, that's it.